Hey guys, so in this video, I just want to do a little bit of review. I have a lot of videos on factoring now, so I'm not going to do a lot of actual factoring. What I want to do in this video is talk about how to know what kind of factoring you're doing. So that's going to be kind of the focus of this video. So we've talked about several types of factoring. We've talked about just factoring out the GCF, the greatest common factor. We've talked about factoring by grouping. We've talked about the AC method with grouping. We've talked about slide and divide. Now, those two last things are used in the same types of situations. It's a personal preference on which one you want to use. And then we talked about some special cases of factoring that make the factoring easier. So I just want to kind of survey through some questions and see what type of factoring we would use. So for this one, immediately I see that I have 4 terms here. Now I've said this in other videos, but I'm going to really hammer it home in this one. If the very, very first thing that you should always do is check to see if there's a GCF that you can factor out of the whole thing. Now, I don't think there is in this one, but you should always check for that first. But this, I would look at this, I would see 4 terms, and I would say, okay, I need to factor by grouping. 4 terms, I'm always going to factor by grouping. So again, that would be factoring out whatever I can factor out of these, and then whatever I can factor out of these. Ooh, I can actually factor out a GCF. Sorry. These are all divisible by 7. So I would do that first, where I would factor 7 out of all of them first. Let me just write out what that would be really quick. So I would factor out a 7. Right, so that would be 4, because 7 times 4 is 28. 5n plus 5n squared minus 2n to the 4th. And then once I had done that, I would factor by grouping. So at this point, the 7 is just along for the ride, and I can factor by grouping. I can just factor by grouping. So I'm going to ignore the 7 for the rest of the time. It's not going to go away. It's going to stay there, but I don't have to deal with it. I can just deal with smaller numbers. So that's one of the reasons that we always want to factor out the GCF first, is so that then we have smaller numbers to deal with. And also, if we don't, then it's not factored completely, and it's factored completely. So if I don't factor out the GCF, then I'm going to end up with something that is not quite completely factored. So I'm going to go ahead and finish this problem. 4 and 5 don't have anything in common. I can't actually factor anything out of that, which is fine. As a placeholder, I'm going to write a 1 here. Now, I know I usually don't write 1s because they're just invisible and kind of obvious, but I'm going to write it there as a placeholder to see if there's something that I can do with the rest of this. So then in this one, I can't factor out anything with the numbers, but I can factor out an n squared. So I'm going to do that. So I'm going to have plus n squared 5. Oops, that's not a 5. Now, just looking at how this is going, I don't think that factor by grouping is actually going to work on this, which is fine because it's good to show you what happens when factor by grouping doesn't work, what that looks like. So you see I factored out the n squared here, so I have 5 minus 2n squared. If I were to distribute this back, I would get this. So notice that 4 plus 5n and 5 minus 2n squared are not the same thing. They're different, right? These are not the same thing, which means that factor by grouping is actually not going to work in this case because these two parentheses are not the same. So I would say, okay, factor by grouping didn't work. This is my final answer. Okay, this is my final answer. Factor by grouping didn't work. So this is going to be my final answer because factor by grouping is the only factoring technique that I know right now that uses 4 terms. So if I have 4 terms and factor by grouping didn't work, then I can't factor. So this would be my solution to this one. Okay, so continuing down, I'm going to look at number 4 here. This one looks like it would be a difference of squares because, again, think about the techniques we've learned. The only one we've learned that only uses 2 terms is difference of squares. But there's a couple problems with that. But first of all, let's factor out that greatest common factor because, again, there's something we can factor out. We can factor out a 2 on both of these. So let's go ahead and factor out a 2. So remember, every time you're going to look for the greatest common factor, you're going to factor that out first. So I'm factoring out a negative 2. Since there's a negative in front, I want to factor out a negative because I don't want to have a negative in front of my first term once I'm done factoring out the greatest common factor. It just makes things way more difficult. So we're going to factor out a negative 2. So even if this one were positive, is what I'm saying. Even if this one were positive, since the first one is negative, I would factor out a negative. So I end up with 5x to the 4th plus, because I factored out a negative, the sign has to change. Because remember, if I did negative 8 divided by negative 2, I would get a positive 4. So this is what I get when I factor out a negative 2. Now notice there's a plus here. For difference of squares, this has to be a minus. I can't use difference of squares if this is a plus. So this, I can't factor this because the only thing that I learned how to factor with only 2 terms was difference of squares. And this is not difference of squares, this is sum. So I can't factor this. So this would be my final answer because I can't factor any further. Okay. So I'm gonna continue down. I didn't expect to be doing so many actual examples, but there are so many interesting types. I want to make sure that we're clear on how to factor them. So again, this one you would factor out the greatest common factor first. So you could factor out a 6MP because they both have that in common. And then after that, you'd be able to see if you can use difference of squares. On this one, you would factor it with that leading coefficient not 1. So either You would use AC with grouping, where you'd say, okay, I'm looking for something that multiplies to -7 and adds to 6. So remember, this negative counts. We're looking for something that multiplies to -7 and adds to 6. And then do the rest of that method. Or the same thing with slide and divide, where you slide the negative over here and then factor, and then you would divide by -1 at the end. It might not be factorable. I don't know. So let's talk about how you tell if something is factorable or not, because we didn't have any examples of that in previous worksheets. If you can't find something that multiplies to -7 and adds to 6, if there isn't a combination that exists that does that, or whatever it happens to be. Like, for example, if there isn't something that multiplies to 90 and adds to 19, there is, it's 9 and 10. But if there isn't something that multiplies to 90 and adds to 19, then it's not factorable. So you have to check all of your possible factors, or if you see right away what it is, then you don't have to check. But if you're not seeing it, check all of your factors of the last number, or the first number times the last number, if this is not 1, right? And if none of them add up to the middle factor, then that's not factorable. So if you can't find factors that work, if they don't exist, then it's not factorable. So just trinomials like this, you're just using, this would be straight factoring, because this is 1, so you would just, 9 times 10 equals 90. So 9 times 10 equals 90, and 9 plus 10 equals 19. So 9 and 10 are my factors. So this would just be simple factoring. I don't have to do any special tricks. Of course, if there's a number out here, then I have to use either AC with grouping or slide and divide, or some other trick to help me factor. So with something like this, I would do one of those. Again, here I can factor out a greatest common factor, and that's it. Here I would factor out a greatest common factor before I factor. So I would factor out that -4, because I can divide all of these things evenly by -4. So I would factor out that -4 first, and then factor the rest. We had one like this in the quadratic methods video. Please look at that for how you would factor this. You can factor this. So if you have one thing on one side and a different variable on the other side, and then both of them in the middle, you can factor that. Please look at the quadratic methods video for that. Also, you would factor out the GCF first. So these are all divisible by 6, right? So you'd factor out a 6 first on that. So remember to always be looking for those GCFs to factor out first. Yeah. So basically, yeah, those are the different types. You have your regular factoring, regular factoring with the coefficient not 1, which is you're going to use AC with grouping or slide and divide, something like that. You have your special cases of difference of squares and perfect square trinomial. Didn't really talk about perfect square trinomial. Honestly, perfect square trinomial is the harder one to see of the two, to see, oh, this is definitely a perfect square trinomial. If you see one that has a perfect square in the beginning and a perfect square at the end, the first term and last term are perfect squares, and you want to check to see if the middle term follows the pattern, go ahead. Other factoring methods will also work on those as well, so you don't have to use the trick, but if you want to, go ahead. And then we also had factor by grouping. So those are kind of the thing. And not everything factors. So like this one didn't factor. So just be aware that you could get to a point where you're like, oh, whoops, this doesn't factor. And then you just say, okay, well, the previous step must have been my final answer then, because this doesn't factor. But make sure you're always factoring out the greatest common factor and doing that first. Do that first, because that will definitely simplify things for you. And it's just correct to have that first, and then you're going to have smaller numbers, and it's just better. So yeah, like for this one, for example, I could have done grouping first, but then I would have seen that it didn't work, and then I would have said, oh, I just can't do anything with this, and I might not have realized that I could factor out the 7 if I hadn't looked for that first. So make sure you're looking for that first. Okay, so hopefully this helps. I know it's kind of long, but we've done a lot with factoring. So yeah, so hopefully that helps. Let me know if you have any questions, and I will see you in the next video.